The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to the Creo Mold Analysis webinar presented by Boundary Systems. Today, I'm Sean Farrier, and I'll be your host for this walkthrough of our review for the Creo Mold Analysis Extension this morning, or this afternoon, I guess, if you will, I suppose, depending on your time zone. We're going to have a short presentation. I'll cover some slides. And then after we cover some slides very quickly, we'll kind of dive right into the software. So without any further delay, we'll kind of go ahead and get started here. We're still collecting a few attendees just to kind of give everybody some basics about the webinar. If you're a new participant in GoToMeeting, or excuse me, GoToWebinar, we're going to have everybody on mute for the course of, the webinar, hopefully except myself. And once we get done with the webinar, then we'll go through a process of either raising hands or, depending upon, the amount of background noise, and if everybody can kind of mute the phones on their end, maybe we can just open it up for some question and answer or something to that effect. But during the course of the webinar itself, we do keep all the participants on mute. So go ahead and make sure to either send your questions over through the question functionality in the webinar, or possibly as a chat message, or just write them down, and we will try and catch up to that when we get done with the webinar, if at all possible. So without any further delay, we'll go ahead and get started here today. So our agenda for today is going to be, as I mentioned, a little introduction to both myself and Boundary Systems with a few slides. That'll go by probably pretty quickly, and then we'll have our mold analysis demonstration, and then we'll move on to a little bit of Q&A, as I mentioned. So a little bit about me. I'm a Boundary Systems technical specialist. I've been working with all things PTC products, if you will, maybe not all of the product suite, but quite a bit of it. Since about 2001. I get called upon by Boundary Systems for training, consultation, and implementation of software typically, and webinars too. So Boundary Systems, a little bit about us as a company, definitely a technology leader throughout the eastern half of the country, partnered with a lot of big companies, as you see here on the slide, providing all types of capabilities to those clients, product lifecycle management, data management, CAD and consulting, product development, simulation. All these things are things that you definitely reach out to Boundary Systems for in terms of getting technical help and expertise. Some awards that have been bestowed on Boundary Systems in the pseudo-recent history. Definitely Boundary Systems being recognized for the accomplishments and the good work they do for their clients. This slide that you'll be seeing now kind of covers some of the software partners that Boundary Systems works with to solve problems for their clients. PTC being the primary partner and obviously the focus of our discussion today. And my contact information is now shown on this slide. Once we're all done with a webinar, I typically, once we've got to the end of the presentation, I usually put and it'll have this same slide of information on it. I'll put that back up at the end of the webinar if anybody fails to get it right now, so that you can grab that contact information, at the end when we're wrapping up or whatever the case may be. So with that, we'll go ahead and start our webinar. So we've got a prepared project, if you will, a little bit here to use for the Creo Mold Analysis demonstration and webinar review today. When we speak to simulation products as a whole, which this is a simulation product, they tend to take a little bit of time to do the thinking part of what they do. And rather than boring everybody today while my computer's crunching numbers and we're all watching grass grow, I've gone ahead and pre-established a project on this part. We'll walk through the process and the steps that become the front side of getting to the point where we let it go crunch the numbers and bring us back the information that we'll also be taking a look at from the pre-calculated project. But we won't have to sit here and wait for it to actually calculate today in the interest of optimizing everybody's time. So, Creo Mold Analysis. Creo Mold Analysis is an application that we access through the Applications tab here inside of Creo Parametric. Inside of Creo Parametric, we have the Mold Analysis option that allows us to start the CMA application. Now, I have a simple Creo part file on the screen here, and I'll kind of spin it around to give everybody a couple of different views on it here. It's just a simple, pre-established part in Creo. The Mold Analysis Extension doesn't have any restrictions as far as the design of your part. It works on parts at PRTs as opposed to assemblies and drawings, but it doesn't have an expectation that there are advanced design requirements or something to that effect. If you have previously designed work and would start using their Creo Mold Analysis on those previously designed parts, that would work just fine. There isn't any preparation or any special sauce, if you will, that goes into the part in and of itself. The parts are just simply Creo parts. You can kind of see the feature tree that exists here for this part that I created for the purpose of this demonstration here. It's just a simple feature tree. There is nothing here or nothing needs to be here for the purpose of mold analysis itself. We simply register a part to the screen, open up a PRT, and then go ahead and start the Creo Mold Analysis application. Once we start the Creo Mold Analysis application, we obviously have the Mold Analysis tab added to the ribbon, and we're now in our mold analysis environment. As we see that we've got everything here, we've got a host of things here on the ribbon that are available to us to do mold analysis type functions and review the results that are provided by the mold analysis simulation. We have the ability to save and retrieve projects, as you'll see here. Basically, we can, create an analysis, as I've done with this part, and using a given set of parameters, and then save not only the parameters themselves, but save the results of the calculation so it can be recalled later, and the time it takes to actually do the number processing doesn't have to be repeatedly waited on. A previously defined file set can be recovered to later and reviewed as it is. But as you see, it doesn't change anything on my Creo PRT. The information is stored beside the PRT, if you will. It's not stored into the PRT itself. So my PRT, for the purpose of the Creo Mold Analysis, doesn't get alterations or require any specific changes. This completely runs sidebar. If we were to establish a simulation from scratch, as you can see, we have, most everything is grayed out in the ribbon right now. The reason most everything's grayed out in my analysis ribbon is given that I don't have one. I haven't loaded one yet, and I haven't performed one. We can see that it's been dim down except for the areas that I might start to engage with. I can select or edit a material for an analysis here using my material icon. The material library that is embedded to the Creo Mold Analysis Extension is in fact quite extensive. I don't quote me on the number specifically, but it's been historically indicated to me that there are thousands and thousands of materials available here that can be searched by producer or by family, and the criteria for the material when you would otherwise select it would be provided. You're given information not only for physical and mechanical properties, but viscosity and PVT for the selected material as well. So I believe there's also functionality to define a custom material, as you see here, in the interest of, doing an experiment, or possibly you are working with a supplier and have a small custom blended lot that you are going to do some experimental molding or something to that effect on. You could subsequently make some changes to an existing material to create your custom material, or otherwise enter this from scratch and then have a material that would hopefully be more in line, from a simulation standpoint, if you were pursuing simulation for that project, that was in line with the material that you were actually using. But the material library is very straightforward. You simply search the material library by producer or by family, and I'm very sure that those in the plastic industry are familiar with the meaning thereof. You're either searching by the type of material, to speak to it generically, say polypropylene or nylon, for instance, or you might be searching by material supplier, being in examples of Dupont or A. Schulman. So the material library is very, very deep and very powerful to zoom in on the material that you need to use for your simulation. Gates can be handled two ways in this case. We can do a direct gate specification ourselves, or we can do an automatic gate creation, okay, where the system will mathematically create, mathematically evaluate the part topology in the interest to find an optimal gating location. This is done mathematically without consideration for part quality or tooling implications. So it is worth noting that the ideal location as mathematically calculated for the gate, at least in my historical experience, doesn't have a high degree of probability to be the tooling or quality necessary location for the gate. But in the case where we do not know, or we have flexibility to tool with some variation for the part when we do get to molding of it, if you will, the automatic gate creation can help you kind of get an idea, generally speaking, or even somewhat precisely so, as to where the ideal location on the part would be for the gate. We can simply select the gate. If we're putting a gate on manually, I can simply select to create one. We would simply then enter the gate setup dialog, and we would select a part location to add for the gating. So if I wanted to gate right there in that location, I would simply select on my part there in that location. And as you'll see on your screen here in a second, it goes ahead and puts a visual marker there, kind of sets things up so that it's obvious to the user where the gate's been located. And then you are prompted by the system to enter the orifice size for the gate, in this case, that'll be used for the purpose of simulation. So you get to pick your location and the orifice for it, and you can continue to add multiple gates to a single part, or you can just operate with one. So that would cover our gating functionality, and then we would have the analysis tab going to our right. It's very well and very cleanly established on the ribbon for the Creo Mold Analysis Extension. It's very easy to use. The workflow is very left to right across the ribbon, and providing the user a clear pathway to where they need to go next. So if we were establishing the simulation, having picked our material and established our gate on the part, if you will. Our next order of business would be our analysis. It didn't find a gate because I didn't complete that process, so I'm going to have to go back and actually put the gate on there so I can show you how the analysis setup actually works. So there we go. So we quickly went back and went ahead and deployed a gate onto the part now, so we do have one formally. The idea there being is that the system's also doing some degree as necessary sanity checking for the inputs. Simulation calculations tend to take a long time, or can, if you will, depending on part volumes and accuracy settings, and we'll get to those here in a minute. But basically the idea being is that we're going to check our inputs to the highest degree possible, because it's really unfortunate to spend a long time thinking about something and calculating with a missing input or something to that effect, wherein it, goes for a long time before you're informed that, that the wait was for nothing. So now we've entered our analysis setup dialog, and that would be the next stage in our process of the workflow of simulating, doing a flow simulation on this component. So in this case, the material that is selected is an ABS, a Schoenman ABS. I can select materials here, and this will allow me to go right back to and change, if I change my mind, the material that I would otherwise be using for the purpose of this analysis. So even if I previously defined my material during the course of declaring the analysis, I can change it there. You get some basic, as necessary, process calculation input information from the user. We're going to get that basic information is going to be declared as filling time, melt temperatures, and maximum injection pressure. The filling time is a system automatically calculated value that you can change to suit your typical molding experience or assumptions about the part as to whether or not it would be fast fill or slow fill, etc. The melt temperature, mold temperature numbers, and some of the injection stuff, that information can obviously be changed as case by case on the fly for each analysis. However, some basic middle of the road, if you will, guidance is provided from the material library and the internal calculations based on the volume and the geometry of the part, so that the user does get some pretty reasonable numbers to start with. Fill time may or may not be as typical to what the user's expectations are, but with respect to the temperatures and the pressures, as we would be doing a CAE type analysis like this, these values are usually not necessary to change by the user. The system usually has a pretty good values coming in out of the gate. So typically the big thing that the user will calculate on, or excuse me, concentrate on, will be the filling time and the mesh element size, which we'll be talking about here in a second, which you see at the bottom of this dialog. Those two settings are really the big engagement for the user for declaring the simulation. And arguably, it's just that simple. We've got a couple of values that we kind of focus on a little bit. What are we thinking for fill time? And how accurate do we want the simulation to be? Being the second one down here. Beyond that, there's not a lot that the user has to know or do. The user does not need to be a CAE simulation expert to get good results and to accomplish the process of the simulation. The software is very, very well optimized and very much set up for quick and easy entry, expedite the user's time, let it calculate, and let's have a look at the results. So we can also elect to calculate the maximum cooling time and or calculate the presence of sink marks as a part of the calculation here. We can otherwise turn those things on. You'll notice that my calculate fiber orientation is grayed out. This material doesn't have it, so the system's going to gray that out automatically. Again, it's some of that user checking like I ran into with the gate today, in so much as that we wouldn't want to turn on inadvertently if the product is being used maybe by an engineer not well versed in CAE and plastic injection mold simulation, may turn on something like that in a case where it's not applicable, and the simulation may take longer to calculate because it would be running unnecessary equations. So in this case, we can turn on and off our fiber orientation, but only so when the system understands that it's applicable to the material that we're using. So the last part of what we set is potentially some of the most important here, you know, if you will, where the rubber meets the road. You have a three, you know, a high, medium, and low, or as they describe it, coarse, medium, and accuracy setting for your simulation. When they're talking to the mesh element size, they're speaking to how granular, how precise, how fine, how close to real-world results am I looking to get with this particular simulation. We don't, in the Creo Mold Analysis Extension, we don't get down in the weeds like we might with a more, you know, higher order simulation product like a MoldX 3D, for instance, where we would actually be dealing with the meshing in a different way, or arguably, you know, having more control and more settings to worry about with respect to meshing. The meshing is basically automatic in the context of the Creo Mold Analysis Extension, so we're left to the user only having to deal with the burden of deciding, you know, do I want a low, medium, or high accuracy, and therefore, in parallel with that, what kind of time am I looking to pay for the simulation? As we would increase the radio button to the right, selecting either medium or accuracy in this case, the quality of the result will improve at the price of taking more time to generate. There will be more math calculations ran on more elements, so the process will take longer to calculate the simulation. On parts like this that we have on the screen that have, you know, today, which is very small, the scale of this part is in fact very, very small. It's probably fits within a 1.5 inch cube. Roughly, it's probably not any bigger than, you know, a cube of 1.5 inches. The concept of the accuracy of the simulation versus the time is not substantial. However, if we were simulating large volume parts having a large volume, and especially those parts having a large volume with a high degree of complexity in the topology. In my personal experience, you know, holes that penetrate all the way through shells from one side to the other, and if there was a lot of holes, like if you can imagine simulating something that had a screen or speaker grill or mesh appearance and such to it, those types of high intensity objects with topology, those obviously come with more volume and more time because of that volume. So the user would pay likely more attention to their selection for accuracy in those cases. If you were looking for something very precise, it can obviously be set to accuracy with the understanding that as the part size and complexity grows, the farther we select towards the right, the longer it will take for the calculation to complete and provide us our results for the simulation. So at this stage, I would subsequently make a fill time, make a full-time setup here, and I might set my own fill time. I would tell it to calculate the sink mark and the cooling, and I would select my accuracy value that I wanted for the simulation. And then I would click add. And then it says if you want to change the gate positions, update the layout from the setup dialog, and then run the analysis. So basically what it's doing is it's reminding me, hey, I've got all this information that you've given me and I'm going to use it. If you go change the gate after the fact, the simulation doesn't automatically reflect those changes based on that new gate location. you would go and create and run another simulation, and the simulation saves that gate information so that we can have multiple analysis runs stored within the same data for a given part. And then when we have all of these analysis runs stored to the same part, we can kind of do a switch back and forth review type with the analysis. Maybe we ran an analysis with material A and then changed over and went to material B or something to that effect, and we have multiple analysis that we want to just be able to recall. And that's part of why this dialog is established the way it is. We see here that I have analysis 01 now as pending in my listing for analysis runs. I could subsequently change the material, the process condition, and the element size and gate, and create another one and have multiple analysis listings here within the same analysis information window, so that I can select between those and call up those separate results at a later time without having to go create a whole bunch of simulations over again or anything to that effect. So if I wanted to go ahead and get this information now and go ahead and run the analysis, which is the process of, telling the system to go out and make the calculations, run the equations, do the simulation, create the results, and give it all back to me. Clicking the Run Analysis button would start that process, and then when it got done crunching numbers, we would have a set of analysis results to review. As I mentioned at the start of the webinar, in the interest of optimizing everybody's time, we're going to go ahead and recall now a saved set of analysis information for the parts you're looking at, rather than clicking the Run button and everybody waiting for my computer to crunch that out. So I'm going to go ahead and say close now, and we're going to go ahead and go back to our mold analysis files ribbon button, and we're going to go ahead and retrieve a project now. So I'm going to go ahead and retrieve the project that I have here for this, and I'm retrieving the saved project for the particular part we have been looking at today. So the system is in the process of bringing in all of this information now. So the mold analysis files are fairly large, so it can take a little bit of time for the processing to complete and for all of the analysis information to be loaded to the part file. So here we go. It's completed the process of loading my saved analysis now. If we were to rotate and zoom in the part, you can see this is the location here in the middle of this space on the side that was selected for the gate for this simulation. Just to give us some results, we just arbitrarily, as we did in the earlier part of the demonstration, picked a gate location, gave it an orifice diameter, and away we go. But we see that the gate information is stored with the file set that is saved, so that it is known again later where the gate for the analysis was located. As you can see, now that I've loaded these analysis files, we have a little bit more to do on the Creo Mold Analysis ribbon. We have our Results Advisor available to us. We have the host of analysis results and XY plotting functionality available, and we have the ability to generate reports now. Okay. We'll be looking through a little bit of the analysis, and we'll watch an animation here for a bit, and then we'll talk about the concept of the XY plot and a little bit of view control and making reports and such. We won't dive into explicit detail with respect to each analysis result that we have here today. We'll speak to some of the more popular, bread and butter analysis result options, if you will. However, note that these are the things that are available to you. Moldability, melt front time, air traps, weld lines, sink marks, pressure information, temperature information, frozen layer ratio, cooling time, volumetric shrinkage, velocity vector, and gate contribution. Gate contribution is obviously calculated for a case when it would calculate it for this part, but it would not have, and a single gate will have 100% contribution. Gate contribution is a result that only really starts to have value when we have multiple gating locations on the same object. So in this case now we see that we have a host of results here. So the start of which I might just start taking a look at my melt front time. So I simply select one of these result options from my analysis result group in the ribbon, and then the result is displayed on the part. It's displayed with a legend that is applicable and explained as far as the scale or the units of the legend is also listed here. We're seeing melt front time in seconds from basically 0 to 0.965. And when I have an analysis displayed, and meaning I have selected one of the analysis results to display, then I can take advantage of my view control. My view control provides for, as we see in this case, my view control is providing for sectioning functionality so I can split the part and look through it. I can also walk the section along the part in order to view the information at a different section location. So I can gradually move the slider with my mouse wheel and or just by sliding it in order to kind of progress the section along the part to view that pressure or temperature information inside at a different section location. We can also have isoline display, where we only display it in the theory of an isoline, and the same for slicing display, which removes the display on both sides, if you will, and only displays the position of slice as it relates to the information. Whether that information is in fact related to temperature or pressure is in fact a product of what is selected for your analysis type on the ribbon. So the legend can be scaled. Within the context of my view control, I can control the scale itself that's being used, and I have animations available where they're applicable. Not all of the, not all of the different simulation analysis for Creo Mold Analysis have an animation option, but the ones that do, when you access the view control, it will be there to be available. So we'll go ahead and start the process of displaying the animation, and I'll let that play through a few times. With the disconnect of all things GoToWebinar and the latencies in the web and things, it cannot display, as elegantly as we would like to, but I'm kind of going to let it run for at least a few seconds here so that hopefully, the folks viewing from the other side get a good chance to at least see some of the concept of the filling in animation. What I would say is the filling animation is probably, it does probably look far better in person on your computer screen than it does as displaying across the web because of latencies and whatnot for screen updates. So while regardless of how the animation might be playing on your side right now, it is very fluid and very nice when it's displayed on your own computer, obviously not having those web and internet latencies. So when an animation is available and when it's applicable to a simulation result, it will be made available. You can start and display the simulation, if you will, as an animation and control it in very much the same way we just did the slicing function. I can progress through the steps of the animation in the same slider kind of move, pause type deal, if you will, where I can control the speed at which it goes, and then I can play and pause to a specific location in the sequence of the animation, focus in at an exact time or whatever, or pressure, if you will, depending upon the analysis result that I'm actually looking at. So The view control only activates after I've made a selection for an analysis, and it provides for a way to get more in-depth than just looking at a surface plot and or just playing the animation in and of itself. We actually have inside the volume slicing visibility available to us to see down in. So we'll go ahead and select our air trap result here, and it's probably hard to see on your side, but I'm detecting some air traps in and around the corners and outboard edge of the part as where they would otherwise be expected for something like this, you know, in that type of filling. Air trap does operate on the theory of assuming, you know, perfect venting to some degree, if you will. That's not to say that those air traps will absolutely exist in your mold, or excuse me, in your molded part, but it gives you some inclination to where they might be based on your selected gate and material parameters for the analysis. Weld lines and sink marks are also available to us. We're looking at the sink mark display now as far as the system calculated sink prediction, okay? And again, it's scaled by legend, and I can access the scale by accessing the view control in order to set the upper and lower limits for that scale that I could otherwise change the gradient nature of the plot or whatever the case may be. So in this case, as indicated, you know, in terms of color feedback, where our highest propensity to encounter sinks based on our material and selected gate location for this particular analysis. So we also have some temperature information available to us. Here would be our temperature plot. And again, we can access the view control and slice right into that and see where we are at end of fill with respect to temperature in this case. Okay, we calculated maximum cooling time for this component when I ran the analysis the first time around. So we have that information available to us now to review. That being said, when you calculate maximum cooling time and have the system do that, it will calculate all the way to material manufacturer's ideal target eject temperature. So that may in fact be notably longer than most people or many people actually use in terms of a cooling standard. In my professional experience, that number has been historically much longer than what has been used in a practical sense for most moldings in the real world. But it actually uses that information from the material to calculate the amount of time that's required. But clearly you can see, you know, in this case, we're approaching 30 seconds to cool off the heavy red areas on the part. I would say it's probably very unlikely somebody would leave this in the mold for 30 seconds to cool this particular size of object off. But obviously we can see here in the thick sections, it's going to take some time to get, you know, those areas cooled down completely. So as I mentioned before, we have a gate contribution, but in this case, we see that it turns my entire part the same color because the entire part is in fact, you know, being shot with the same gate. We also have a pressure result, as you see here, and the pressure result would be a result that you can also slice and otherwise review deeper into the part in terms of where, you know, what are the pressures that, if you will, end of fill down through the actual volume itself, if you will. So we also have a moldability result, and in this case, based on the material in question and my selected gate location, it feels that the part, you know, has a decent moldability. That's obviously not an explicit gauge of if everything is going to be okay, but it does help to raise the engineer's confidence, especially if you're using this tool at an early time upstream in a design cycle for evaluating different types of geometries or something to that effect. Our result advisor allows us to bring up information about the results that we have, and it provides for some context and some information to the person reviewing the simulation in the case where they may not take this information for granted. They may not have a great deal of experience about simulation as it relates to plastic injection molding or defects in general as it relates to plastic injection molding. So in a case here, it allows us to select on these two things, and it will display that result. And here, if we see, I'm going to kind of try and get a good view for the audience here on the component, where it will kind of show here. I might have to zoom in some. But as we can see here, if it's coming through, the weld line I'm having a weld line issue down through the center, obviously opposing my gate here on the molded, the hole that is molded all the way through the part. And you can see the red indications of that, significant weld line that we have here. And it's coming up and saying, hey, I found sharp welding angles at some places. The weld lines may become visible. It's giving me some indications that while my moldability is good, I may in fact start to encounter a quality defect in this area. And then it gives me some suggested solutions and some other information to kind of help those that may have a little bit less experience in plastic injection molding defects and or plastic injection molding simulation to kind of get headed in the right direction to see if we can resolve the problem through a change in process, or if it's going to potentially, need for a change in geometry, because this weld line is in fact in a place where we consider it to be a potential quality problem on the final component. And again, it provides for some suggestions to the user for improving the situation. It did find some air traps inside the cavity. This may cause void or surface defect depending upon the type of material used. And you can see the little air bubbles and for their locations. Maybe it's a little hard to display. I'll kind of zoom in here and kind of point at one in particular off the end of my cursor that kind of gives some feedback to where these air traps are likely to be located. Some materials are more prone to having problems with air trap than others. And, tooling also plays a part as venting of the tooling. That you could simulate the part and everything could be wonderful. And if they actually, didn't do a good job of venting the mold when they built it, you could end up with air trap problems in the real world that might not have existed in the simulation for no fault of the simulation engineer or the process they used to get the analysis. But it does give us a place to start looking and thinking about potential problems that may occur as it relates to trapping gas inside of the cavity, thus preventing the part from completely filling or potentially causing burn or other quality visual problems on the molded component after the completion of the molding cycle. So with this, we can also overlay different results with things like an XY plot. So here in this case, I'm going to overlay pressure result with respect to clamping force. So we have a little bit of XY plot functionality available for us. We have 3 different XY plots that can be utilized. In this case, I obviously have the display showing pressure, but the clamping force being what's being shown on the XY plot in this case. We can also overlay that to flow rate. As you see here, my flow rate plateaus very quickly at about 0.097 here in terms of seconds, if you will. And we also have sprue pressure. Sprue pressure may be better displayed against something like, melt front time as opposed to displayed against something like pressure itself. So we can overlay these XY plots with respect to our to our underlying simulation selection as far as the analysis results. In a case where animation is supported, I'm going to kind of play this here. I'll kind of try and see if I can slow it down here a little bit. And I'll slow it down, and then maybe it'll play to the, maybe it'll play through the delays of the web a little better. But what we would, if absent delays on the other end, if you're seeing a good result from GoToWebinar, you're seeing the XY plot being animated and plotted simultaneously with our animation in this case, which would be melt front time. So we're seeing the sprue pressure running right in parallel with the animation of the melt front time, which is kind of nice. It's some very elegant display, very informative, gives the user a lot of information from a very limited amount of inputs to the simulation. And you can turn on and off those displays of things like the legend at will. So at any time you can say, no, I just want to go back to viewing some specific simulation result by itself. You simply uncheck the selection for sprue pressure or whatever your XY plot is in this case, and it no longer displays it. When we generate a report, we are able to generate both PowerPoint and HTML reports. They would comprise the information of this analysis result into one of those packages. And you are given some basic information that you would include with the report. So we might call this a demo report. And if I had an applicable company logo, I could go browse for that, and I could tailor the report specifically for somebody, to a specific recipient and or to include their company. I would be creating an HTML report in this case, and arguably saying include the analysis description. So in this case, I will call this my demo report. I'm going to browse for the location of the report here, and we'll put this in a new report folder. So we're going to create our report now, and then it's subsequently put our insulator report in the specified folder, and we'll go ahead and say OK. The system goes ahead now in this process and is saving out all of the analysis results and creating the report subsequently that I can package up and share with others. The report in this case has been generated. If you'll bear with me for a second, we'll see if I can go ahead and get that report opened up now. Okay, so we've got our demo report open for us to kind of take a look through here today. So in this case, we see that it stores off the general information about the simulation and the actual object in and of itself. It stores out material and process information as well, okay? And then it gives us the analysis summary. And even in the HTML result that I've gone ahead and created, as you'll see here, it actually embeds the animations as GIFs or some other type of web animation, if you will. And we actually have those animations embedded right into our report results, which are effectively stored in this case as, I believe, yes, just a simple HTML file. So I'll put this on the screen here real quick so that we can see that. Here you see the report file that was created. It makes a picture folder and it gives me an HTML that I can subsequently zip this stuff up and share this with others, or inform somebody on our, within my local company network where it's at, and then they could simply come and open this up with any browser, typical internet browser, Internet Explorer, Firefox I'm using today, whatever the case may be. So we see the results are all included, the moldability result, air trap results, weld line information, the weld line results, basically all of those things that were on the result tab, or excuse me, analysis results tab, are embedded into the report. So the report contains quite a bit of information. You see a bulk temperature result. There's many results are here that we didn't even get a chance to look at today inside of the report itself. If somebody would want a copy of this report or something, just for the purpose of, just getting an idea of what can be had from the system in terms of that, I can obviously share this out to you, no problem. Just make sure you drop me a line via email, and again, I'll put my contact information up here in a second when we open up for question and answer. And if somebody would want to take a look at a greater depth at this report that was generated and the information in it, I'd be happy to forward that off to you. So with that, I'm going to go ahead and close our report that we created. We've covered basically from beginning to end, minus watching or sitting through the calculation time. We've covered a complete process of the Creo Mold Analysis Extension at this time. So with that, I'm going to go ahead and see if we can, I'm going to minimize, or at least for now here, I'll put my minimize Creo. I'm going to put my contact information back up on the screen now, and I'm going to go ahead and open the floor up for questions at this stage. If somebody has a question, it might work best if you use the GoToWebinar interface to raise your hand, and I'll go ahead and try and speak to your question or unmute you specifically, rather than unmuting everybody, because we did end up with quite a few participants at the end of the webinar today. We still have 14 attendees, so typically that's a few more people than what I can just do an unmute all with, and still have everybody to be able to hear and work through that process. So if need be, if we can go ahead and use the raise hands, or you can use the chat functionality inside of your GoToWebinar interface. If you want to either use one of those two things, either by pushing a question forward, raising your hand, or pushing a question in through the chat functionality, I'd be happy to take I suppose we've got somewhere between maybe 5 to 10 minutes here remaining before we hit our 1 hour limit here, and I'd be happy to take questions during that time, and very pleased to do so. So if there aren't any questions, I thank you very much for your participation today. It was a pleasure to get a chance to share the Creo Mold Analysis software with you today, and I look forward to any questions that you might have. You're obviously welcome to reach out to me directly with questions at my email address that's on the screen as well. If your time is short today and you have maybe a more involving question or something about the software, don't hesitate to jot down my email address there and fire that question off to me in email, and I can respond to that also. If you have questions about licensing or purchasing the actual product that is Creo Mold Analysis Extension, please reach out to our sales department at sales@boundarysys.com. So again, with that, I'm going to go ahead and be a little quiet as I sit here and wait and pay attention. If I get somebody that's going to maybe ask a question or something to that effect, I'll go ahead and speak to that. Okay. So if I'm not getting questions, I won't be speaking. I do have one question here coming in now, so let me go ahead and take a look at that. Oh, I guess that was just a reply by somebody that was leaving. My apologies. It looks like that person has already exited the actual webinar. So please don't hesitate to reach out and ask a question through the chat window or the actual questions dialogue inside of the GoToWebinar interface. So I will continue to be here. It's by my computer clock, it's 12:23. I'll go ahead and keep my contact information up and be ready for questions up until the 12:30 cutoff. So even if I'm not speaking right now, I'm here and I'm available for questions. If somebody's got one, please don't hesitate to type that in so I can get a chance to speak to that. Okay, we did get a question coming in. An individual's asking is there any distinction between Creo 4 and Creo 5 as it relates to the mold analysis extension? And because we got a little bit of time and it's my first question, I'm going to go ahead and I'll go ahead and start up Creo 4 here, and we'll take a quick look. I don't remember specific, I don't have a what's new document in front of me. I don't remember specifically that there were significant changes to the Creo Mold Analysis Extension in 5, but there might have been improvements, there might have been changes. I don't remember right off as to what, if any, specific changes there are in terms of the software. If there is, it's probably pretty light around the edges in terms of the workflow and using the software with the Creo Mold Analysis Extension. I don't believe it to have been any different in version 4 and accessing it and being the same than it is in version 5. So let me see if I can, in fact, open something. I know that project that I was using today is, in fact, done in Creo 5, so I may not be able to open that project, open anything from that project into Creo 4. Let's see here. Yes. No, okay. But accessing the application is basically going to be the same. I don't apparently have a part I can open up quickly and easily here. Whoops, I started simulate. That wasn't what I had in mind. Whoops. I don't believe it. I guess to make short of it, I don't believe it to be any. I don't have a part. This project wasn't ready that I can go back and open that in Creo 4 and obviously take a look at that. It's been saved off into Creo 5. I don't remember any significant differences between the Creo 4 mold analysis extension and the Creo 5 mold analysis stuff that I'm running. So I apologize that I didn't have a side-by-side ready to go to compare project in version 4 with a project in version 5. And I hope that speaks to the participants' question, in spite of that I wasn't kind of ready to show them side-by-side. Don't hesitate to ask another question for any of the remaining participants. We've got a couple of minutes here that I can definitely sneak in another question or two if somebody's got one as far as that goes. We still have, upwards of 10 participants. So I don't think we can unmute everything yet and kind of try and maybe do just a global question and answer. If we get to a point of about 5 participants or less, give or take, that usually seems to work, but we've still got quite a few people participating. So just reach out either through the chat functionality or through the question and answer, and hit me with any questions if they come up. Otherwise, we'll close up our webinar here at 12:30. Okay, I want to thank those of you again, excuse me, that took the time to participate in our webinar today, and I hope it was informative, and I hope it gives you the good information that you might have been looking for as it relates to the Creo Mold Analysis Extension. I've got my contact information and our sales team's contact information up there on the screen for you right now. We'll be wrapping up the webinar here any minute, and again, I'll close this up, but if you need to, take a screenshot of that or whatever the case may be so you can reach out to us in the future. If you've got additional questions about the Creo Mold Analysis Extension or its capability, or you'd like to reach out to me for a copy of that report to take a look at in greater depth than what we had the time for today. So with that being said, again, I want to thank everybody for their participation, and I wish you a very good afternoon. Have a great day.